This is problem-solving strategy for 2D kinematics. You're going to want to use these methods whenever the velocity is given at an angle. Split the velocity into vertical and horizontal components. Because the velocity is at an angle, you have to find v in the y direction and v in the x direction. Use trigonometry to do this. V cosine theta, the angle it gives you, is Vx. V sine theta is Vy. I recommend making an x and y chart to record the values in the x and y components. Remember that t is shared among both components because the projectile will land at the same time for both. Also remember, acceleration in the x component is always 0. Generally, the only formula you're going to want to use for the x component is delta x equals vxt because there is no acceleration. The key for 2D kinematics is to find the time it takes for the projectile to land. This is always done in the y component and can be used in the x component. So now we have a problem. The Hulk from the Avengers jumps with a speed of 30 meters per second at an angle of 70 degrees to the ground. Calculate the horizontal displacement of the Hulk. So now we can use what we learned to solve this problem. Horizontal displacement, or delta x, is what we're trying to find. Using the velocity that we're given, we can find Vy and Vx. We split the velocity into horizontal and vertical components. The angle, 70 degrees, will be used in trigonometry to find these two velocities. Sine 70 degrees is Vy over 30. Cosine 70 degrees is Vx over 30. We find that Vx is 10.26 meters per second. Vy is 28.19 meters per second. We're looking for delta x. We have delta y as 0 meters because when the Hulk lands, he hasn't been displaced at all. He's still at the same level. A for the x component is because there's never any acceleration in the x component as long as it's a projectile. A for the y component is negative 9.8 meters per second squared because the Hulk is a projectile and all projectiles on Earth have an acceleration of negative 9.8 meters per second squared. The time will be shared among both x and y components. To find this time, we use the kinematics formula delta y equals v naught yt plus 1/2 at squared. We find that t is equal to 5.75 seconds. Now we can use this time in the formula delta x equals v naught x times t to find that delta 58.99 meters.